Problems on divergence theorem. So if d bar is equal to x square yz bar yz square x bar plus x square yz ay bar plus x y square z square plus a bar z, then calculate the total charge within the cube defined by having values x is in between 0 and 1, y is in between 0 1 and z is in between 0 and 1. So how to solve this problem? There are two steps. First step is using the divergence theorem, calculate the rho v, and the second step is calculate the total charge by using equation of Q. So we write here step 1. Step 1 is calculation of rho v. So we have d bar is equal to x square y z square ax bar plus x square y z a y bar plus x y square z square plus a z bar. This is equation 1. So now using the divergence theorem, we write here now using divergence theorem we have rho v is equal to tan to d bar, so it is equation 2. Now next is the equation d bar is given in the Cartesian coordinate system, so we use the equation of divergence in Cartesian system. So we write here the equation of d bar is given in Cartesian coordinate system. So we use the equation of divergence in Cartesian system. Therefore rho v is equal to delta into d bar, that is delta dx by dx plus dz. This is equation 3. Now we have the general expression of d bar in Cartesian coordinate. General expression of d bar in Cartesian coordinate system. So the general expression is d bar is equal to dx x bar plus d bar ay bar plus dz az bar. This is equation 4. So now we compare equation 1 and 4. Compare. So dx is equal to x square yz square dy x square yz dz xy square z square. So here two xy z square, it is equal to x square z and 2xy square z. So putting these values in equation 3. So put these values in equation 3. So rho v is equal to 2xyz square plus x square z plus 2zxy square. Now next is step 2. Total charge in volume is given by, so it is q is equal to integration of, where since dv is equal to dx, dy and dz, that is differential volume of q. Write here differential volume of q. So q is equal to integration x equal to 1 integration 0 to y is equal to 1 integration 0 to z is equal to 1. So while the value of rho is 2xyz square plus x square z plus 2zxy square into dx, dy and dz. So we solve this equation. So it is q is equal to 2x square by 2 y square by 2 0 to 1 0 to 1, and here it is z cube by 3 0 to 1 plus x cube by 3 so we substitute these values of the limits. So it is x square by 2 So this is the answer, that is 0.5 coulomb. Next problem is, in the cylindrical coordinate system, d bar is given as a d bar equal to 20 r cube by 3 ar bar in the region of r having value 0 to 3 and d bar is equal to 725 by 5 r ar in the region r greater than 3, then find the charge density in both the regions. So first we find the charge for the range 0 to 3. So we write here case 1. So case 1 is for the range 0 to 3 meter. So the divergence theorem in cylindrical system system is given by dot d bar is equal to 1 by r dr plus 1 by r d phi by this is equation 1. So this is the divergence theorem in the cylindrical system. So now what is given equation? Given equation of d bar is d bar is equal to 20 r cube by 3 a r bar. So dr is equal to 20 r cube by 3. This is not dr, only dr is equal to. Now this equation does not contain a phi and a z term. So we write here this equation contain a phi bar and a z bar terms. So equation 1 becomes dot d bar is equal to 1 by r divided by delta r d by that is equal to 1 by 3 d by d r into 20 r cube divided by 3. So by solving it we can write here 1 by 3 1 by r, here it is 1 by r not 1 by 3, 1 by r d by dr 20 r raised to 4 by 3. So that is equal to 1 by r 20 into 4 r cube by 3. That is 80 divided by 3 r square. So dot d bar is equal to, by solving we get 26.67 r square. Now what is given? Now we have charge density. Now we have that is equal to rho v is equal to 8.89 r square, that is equal to 220 r square. Now second case. What is second case? For the range r greater than 3. So here d bar is equal to 725 by 5 r into a r bar. Now using the divergence theorem, use divergence theorem in cylindrical coordinate. In cylindrical coordinate system, it is d bar is equal to one by r d by dr r dr, that is equal to 1 by r by dr r into 725 divided by 5r. So it is 145. So d bar is equal to 0. As 145 is constant, so derivative with respect to it is 0. But what is charge density is equal to rho v, that is d bar. So value of rho v is 0. This is the answer. Next problem was asked in university exam 2 times. So the problem is given that d bar is equal to 5x cube by 2 ax bar. Evaluate both the sides of the divergence theorem for the volume of the cube per meter cube 1 meter on an edge centered at the origin and with the edges parallel to axis. So there are 3 steps. First step is place the given cube in the Cartesian coordinate system. Second step is write down the divergence theorem and prove LHS of it. And third step is prove the RHS of the divergence theorem. So first is step 1. We write here the given cube is 1 meter on the edge. So it is 1 meter. The given cube is 1 meter on the edge. It is centered at the origin. What is given? It is centered at origin and its edges are parallel to the axis. So this cube is placed in Cartesian coordinate system. So this cube is placed in Cartesian coordinate. This cube is placed in Cartesian coordinate